Hi everyone, I'm Justin Joseph and I'm a staff AI engineer working for Analog Devices at their European Research and Development Center in Ireland. Today, you're about to see 4 enterprise capstones built on datasets simulated from industry use cases, not tutorial projects, not toy demos. And all the 4 follow the same core pattern, the hub and spoke multi-agent architecture, where you have one orchestrator which coordinates specialized worker agents. Each agent having its own tools, its own responsibilities, its own scope. And let me show what you're actually going to build. Which takes us to project number 1, the healthcare or the clinical intelligence system for healthcare. Now, the use case is that the patient data is living in silos. The lab results in one system, the radiology reports in another system, and allergy records probably elsewhere. And the doctor has to manually piece this information together. Missing a cross-reference, for example, between medication and an allergy, that's patient safety risk. And your system is designed to mitigate this by building 4 agents, where you have the first agent, which is the lab interpretation agent that queries structured lab data using SQL and LOINC codes. Your CBC panels, your liver function, kidney, thyroid, etc. Then you have the radiology agent that runs semantic search over X-ray, CT scans, MRI text reports, etc. using ChromaDB. Your safety agent that cross-references active medications against allergy records that catches contradictions. And a clinical orchestrator that routes every request based on the patient's context, the doctor's role. In order to discuss more about this, we have to deep dive into the code patterns. And we are discussing 4 of them, where pattern number 1 is hybrid search. The idea is that your medical retrieval cannot rely simply on vector search. You should combine semantic embeddings with keyword filters. Searching for patient with fatigue, for instance, semantically, while also filtering for the exact hemoglobin value. Then you re-rank the results by relevance. And this is how you get retrieval that actually works on clinical data. Pattern 2, the reflection loop. Before any response reaches a doctor, it's validated against medical guidelines. If the system's confidence is low, that is below a certain threshold, it doesn't guess. It pulls additional context and re-evaluates so that the system's confidence in the response or in the right response increases. The final output includes a confidence score along with the source references. And this is the pattern that separates a demo from a production system. Pattern 3, your role-based access control at an orchestrator level. The physicians get full clinical access. Nurses see lab information and medications. Admins see demographics and scheduling. You implement this in the orchestrator's routing logic. Before a request even reaches an agent, the orchestrator checks what this user is allowed to see. And pattern number 4, your LangFuse observability. Every reasoning step, every tool call, every decision that the agents make are traced and logged. When something goes wrong in a multi-agent chain, this is how you debug it. You don't use print statements, you use structured traces. Now looking at the dataset, you will work with actual clinical documents, 39 of them. Lab reports, radiology results, allergy records, patient histories, and not synthetic data. Moving on to project number 2, the BFSI Regulatory Compliance system. You will build a parser agent that takes regulatory PDFs and converts them into structured requirements using PDF Plumber and GPT-4 Vision. A gap analyzer does semantic matching between those requirements and internal policies, scoring each one. Everything is fed into a knowledge graph, which you will build using NetworkX. The regulations mapping to requirements, which maps to policies, which maps to controls. For example, ask what controls safety requirement 4.2.1, and the graph is going to answer it. And every output cites the exact regulation page and paragraph, which is your report generator, and 22 regulatory documents from IRBAI and MAS frameworks will be used for this. Now moving to project number 3, the e-commerce competitive intelligence system. You have Scout agents that crawl competitor catalogs and extract pricing data. You have the analyst agent that handles entity resolution using embeddings. The same wireless headphones appear under different names on different platforms, and the agent groups them together. Then the strategist agent makes pricing recommendations through tool calls. For example, calculating the margin, checking the inventory, getting the elasticity, etc. And the agents decide which tools to call based on the product context. And for managing all of this, you have the orchestrator. Now, you track the cost per agent per query across the entire pipeline. 60 plus stock keeping units across headphones, smartwatches, speakers, etc. will be used for this project. And project number 4, your supply chain contract intelligence system. In this project, you process MSAs, SOWs, NDAs, amendments, etc., where your extractor agent pulls structured terms, parties, dates, SLA values, liability caps, etc., which will be validated through Pydantic schemas. And you will have a graph builder that maps relationships and obligations across contracts using NetworkX. You will have a risk assessor that monitors external news signals and queries the graph for exposure. The architecture uses GraphRAG, combining vector search for semantic matching with graph queries for structural relationships. And it scales. You have a queue-based processing through Celery that handles batch jobs. 500 contracts processed overnight. 36 enterprise contracts across IT, consulting, and manufacturing will be used for this project. And that is your 4 production-grade systems across 4 industries, all built on real enterprise datasets. And if you want to build these, book a call with your program advisor. Thank you and have a great day.